Hello my friends, welcome back to this model selection section. In the previous tutorial we implemented the K-fold cross-validation technique, which is a new tool you now have in order to measure the most relevant way the performance of your model. And now I'm giving you an extra tool, which is grid search, and which will allow you to find the optimal values of the hyperparameters in any model to therefore get an even higher accuracy than the standard version of the model. So we're going to work on the exact same data set, social network ads, so I'm not going to remind this again, and therefore let's open our grid search implementation either in Google Collaboratory or Jupyter Notebook as you wish. And actually this grid search implementation is exactly the same as this one, only we're just going to implement one extra cell, which will be the cell applying grid search to find the best model and the best parameter, the best model version actually of the kernel SVM. All right, are you ready for this? I'm sure you are, so let's create right away a copy because this file is in read-only mode and we're gonna re-implement that cell building the grid search technique. Okay, let's now remove this because we're gonna work with our copies, and there we go. Now let's scroll down to find that cell implementing grid search. Let's remove it, put it in the trash, and there we go. Let's apply grid search to find the best model and the best parameters. All right, so let's create a new code cell. And now the first thing I want to do is actually go to the Scikit-Learn API, there we go, to show you actually again the class that implements the kernel SVM model, because I actually want to show you the hyperparameters which we can tune to find that best version of the kernel SVM model. So here, take the first link, that's the Scikit-Learn website. Then please go to API here, to find all the classes and the functions. And remember, kernel SVM is actually in the SVM section. So we have to scroll down to find the S letter. And we should find it very soon. There we go. Support vector machines, sklearn.svm. So that's the SVM module by the Scikit-Learn library. And remember, the class is this one, svm.svc. Right? If we, check on our implementation, we import this svc class to build this kernel SVM model with a radial basis function kernel. Okay? All right. So K-fold cross-validation, grid search. There we go. Back in the Scikit-Learn API, well, the thing I wanted to show you was that indeed the kernel SVM model has a lot of hyperparameters. I remind that hyperparameters are the parameters which are not learned during the training process. These are different parameters than the weights or, the coefficient of the model. And these hyperparameters are, well, there are many of them. You have the C parameter, which is the regularization parameter that you can tune to actually improve the training performance by reducing overfitting. I remind that overfitting is a situation where you have a high accuracy on the training set, but a poor one on the test set, which means that your model was overtrained on the training set, too well trained, and we definitely want to avoid this. So that parameter is actually very important, and we will tune it to find the best value. The default value is 1.0, but we will try several values. We will try 0.25, 0.5, 0.75, and 1. Because as you can see, it's important to notice this, the strength of the regularization is inversely proportional to C, meaning that the lower is C, the stronger will be the regularization. So, we're going to try the value of 0.25, which will be therefore a strong regularization. We'll try 0.5 as well, still quite a strong regularization, 0.75, less strong regularization, and 1. And we can even try, 0.25, 0.5 as you want. Feel free. I will actually improvise this a bit. I'll see what I end up choosing as the values of C will experiment. And then we have the kernel, so of course that's a very important hyperparameter, and we will actually tune it, meaning we will find the best kernel of the kernel SVM model among these ones. So we'll actually try both the linear one and the RBF one, but feel free to also try, for example, the poly or sigmoid one. And then I would also like to tune this parameter, gamma, which is a parameter you only enter when you choose either a RBF kernel or a polynomial kernel or a sigmoid kernel. And since we're going to tune the linear and RBF kernels, Well, for the RBF kernel, I would like to tune, different values of gamma to actually find the best one. And actually, we will try all the gamma values from 0.1 to 0.9. Okay? And gamma is, of course, the coefficient in, the formula of the kernel, which Kirill and I have already showed you in part 3 classification. All right, so let's tune these 3 parameters. And if you want to tune more of them, well, feel totally free. Or if you want to tune more values of them, but you will see that already with this tuning, we will get an excellent performance. And speaking of performance, actually, it's important to highlight that each time we will try these, different combinations of these hyperparameter values, well, the accuracy of the model will be evaluated through k-fold cross-validation and not on a single test set. Okay, so we will have super relevant measures of the accuracies for each of the combinations of these parameters, and therefore we will be confident that the best set, the best combination of parameters we end up with is indeed the right one. All right, so let's do this. Let's implement grid search now. And of course, as usual, we're going to start from Scikit-Learn. From Scikit-Learn, by the way, let's upload the notebook now so that we can, benefit from Google Colab assistance. Let's click upload here. And there we go. We already have the right folder and we select social network ads.csv. That's the dataset with which we're going to experiment grid search. And so there we go. Now we should get the help of Google Colab. So we're going to start from Scikit-Learn and then same, we're going to get access to the model selection, there we go, module, from which we're going to import this time a class, which is the grid search CV class. There we go. Okay, and now, already in the next step, we're going to enter the different combinations of parameters we want to experiment. And so I'm going to create a new variable here, which I'm going to call parameters. And then I'm going to enter these combinations of hyperparameters we want to experiment within a list. So this parameters variable here will simply be the list of the different combinations of hyperparameters we want to test. And then within that list, I'm actually going to create 2 dictionaries. Why 2? Because actually I want to test 2 different kernels. So in one dictionary, we will have the linear kernel, and in a separate dictionary, we will have the RBF kernel. And the reason why I have to separate these 2 dictionaries is because, the gamma parameter which we want to tune can only be used with the RBF kernel and not with the linear kernel. If it could be used with the linear kernel, then I wouldn't have to make 2 dictionaries. Only one would be fine, and I would just enter the different values of all the parameters which we want to experiment. But that's not the case, so indeed I have to create these 2 dictionaries, which I'm going to put, below each other, just like that. And there we go. Now let's enter the first dictionary. So how are we going to do this? Well, just the way dictionaries work. First, we have to enter the key, and the key is actually the parameter itself. So remember, we want to tune first C, the regularization parameter, then the kernel, and then in the case of the RBF kernel, the degree. And so in my dictionary here, I'm going to enter as the first key, in quotes, well, this parameter C. And then I'm adding here some colon, and right after the colon, I have to enter the value of that key. And the value of that key is exactly the values of C we want to experiment. And we have to enter them in a new list in a pair of square brackets. And as we said, we want to try the following different values of this regularization parameter C, which are, as we said, first 0.25, then 0.5, then 0.75, and then 1. Right, so here on the left we have strong regularizations, and the closer we get to 1, the less strong is the regularization. All right, so that's for this parameter C. Then we can enter a second key within this dictionary, and we have to separate it with a comma. And that second key will be, of course, that other parameter which we want to tune, which is the kernel. And therefore, in quotes here, I'm going to enter kernel, and then for the value of that key, which has to be separated by a colon, well, this value will be once again in a list, therefore in a pair of square brackets, the different values of the kernel we want to experiment. However, since we have these 2 dictionaries to separate the case of the linear kernel and the RBF kernel, because of this gamma parameter, well, here in this kernel list, I will only enter, in quotes, once again, the linear kernel. And now, check what I'm going to do. I'm going to copy all of these, inside this first dictionary. I'm going to paste that inside this second dictionary. And then here, we're going to test the same values of the parameter C, but we're going to test them with an RBF kernel. And therefore, since now we're experimenting the RBF kernel, well then we can add this extra hyperparameter to tune, which is the gamma parameter, which is a new key of this second dictionary. So gamma, and the value of that key will be the list of the different values of gamma we want to try, right? And as we said, these are 0.1, then 0.2, then 0.3, and 0.4, 0.5, 0.6, 0.7, 0.8, and 0.9. All right, good. So you see how this works? We have to enter our parameters into a list, and then inside each list, well, either we don't have to separate some cases and we can put all the hyperparameters and their values into a same dictionary, or we have to separate some cases and we enter them with two separate dictionaries this way. All right, excellent. And now that we prepared correctly our parameters, our hyperparameters combinations, well, time to call that grid search CV class, because indeed, as you can guess, this list of parameters will be one of the inputs of that grid search CV class, or the instance of that class we will create. And well, speaking of the instance of that class, that's exactly our next step here. And so I'm going to create a new object, a new variable, which will be an object of this grid search CV class, and which I'm going to call simply grid_search. All right, then of course we have to call the class to create such an instance. So grid search, there we go, was waiting for Google Colab. Then in parentheses, let's enter the parameters. You can find them on the Scikit-Learn API, but I'll just give them to you now. So the first one is estimator, all right? And this will be equal, of course, to your classifier, just like the estimator argument in the cross-val score function. So classifier, and which is, of course, your kernel SVM classifier. Then next argument. Well, next argument is actually our parameters, the different combinations of the hyperparameters we want to experiment and try to find the best value. And so the name of that argument is param_grid. And this will be, of course, equal to our parameters variable, that list of all the combinations of hyperparameter values. Then next argument, well, the next argument is an important one. That's the scoring, and that's basically the metric with which you want to evaluate the performance of your model for each of these combinations of hyperparameter values. And well, since now we're doing classification, well, the value for this argument will be, in quotes, accuracy, of course. All right, then next argument. So as I told you, each of these combinations of hyperparameters will be evaluated through k-fold cross-validation and not on a single test set. And therefore here the next argument is just to choose the number of trained test folds that we'll have when applying k-fold cross-validation for each of the combinations. And that parameter's name is the same as right here. It is CV. And once again, we will choose the very common value of 10 trained test folds. And finally, a very optional parameter, which you don't have too much to worry about, but I'm adding it here in case you run this code on your machine. This is a parameter that will set how to run your processors, in your machine. And I'm just adding it here with the parameter value -1, which means that all your processors will be used, in your machine, which will optimize the grid search process, because you're going to see that it can be a very long process, to test all these combinations. Well, it can actually take some time. Okay, so that's it for this grid search CV class. We now have our object, and as you might guess, the next step will be to connect this object to our training set. I remind that grid search has to be applied on the training set only, because the test set, once again, is something you want to have separated whenever you want to test your model or, your tuned model, after you tune it on a set of new observations to see how it performs on a data set like in production. Okay, so we will apply now grid search to the training set only. And to do this, well, we're going to call our object grid search from which we're going to call once again that very famous method which you're so familiar with now, which is the fit method. And of course, this fit method takes two arguments as input, which are first the features of the training set, meaning x train, and then the dependent variable vector of the training set, that is y train. Just like a classic training, right? Because actually now we're going to do a lot of trainings, a training for each of these combinations of hyperparameter values. Okay, so that's basically the multiple training. And then there we go. Once this multiple training is done, well, we'll get all the final results, meaning all the different accuracies resulting from all these combinations of hyperparameters. And therefore, after getting all these accuracies, well, we'll get the highest of them, and we'll get mostly the set of parameters that led to that highest accuracy. And so first, let's get that best accuracy, which we're going to put into a new variable, which we're going to call best accuracy. And to get this, well, we're actually going to get it from an attribute of the grid search CV class, which is called best score. I remind that an attribute is just a value we can get from a specific object, and that value here is, of course, the best accuracy taken from that grid search object. So I'm going to copy this, and just below, I'm going to paste it, from which I'm going to call that best underscore score, and then we have to add an underscore again. That's usually how are named attributes. All right, so best score, meaning best accuracy, because we chose an accuracy scoring. And now that we have the best accuracy, well, let's see which parameters led to that best accuracy. And to do this, well, we're going to put that best set of parameters once again into a new variable, which we're going to call best underscore parameters. All right, and once again, to get them, we're going to call another attribute of our grid search CV class, or our grid search instance of that class. And therefore, I just copied this and we'll paste that here, because this time the name of that attribute is best params. Best params, okay? And now we're going to finish this with two beautiful prints. And these prints are actually very similar to the ones we did for k-fold cross-validation. So I'm just copying this and right here, pasting them. And now, instead of printing, accuracy as string, we're going to print best accuracy. Then we're going to keep the same format of, the two decimals after the comma in a float. And for the variable that will get us this, well, of course, this won't be the mean of the accuracies here, but simply that best accuracy variable value, right? This gives directly the best accuracy resulting from the best combination of hyperparameters. So let's just take this and let's just replace that accuracies.mean, the mean function, by this best accuracy variable. And then we have to multiply it by 100 in order to get the accuracy in this format, with the percent format, which we have here once again. And then we don't want to print the standard deviation, but the best parameters. And then I'm just going to print these best parameters the classic way, the simple way of printing something. So I'm just going to remove everything here, that format function and that variable also, because it will be a different variable. And then look, I'm just going to do this. This is the string that will be printed. And then to print the value of that string, the best parameters themselves, I'm just going to separate that string with a comma and then adding the variable that will give us these best parameters. That's just a classic way of printing something with, a string indicating what we're printing. And so here we just need to add best parameters. And there we go, my friends. We're done with this implementation. Well, we're almost done. We just forgot to remove one parenthesis, which was, I think, coming from this format function. But there we go. Now the implementation of grid search is done. So we're going to experiment this now. And I look forward to see which combination of all these hyperparameters will lead to the best accuracy. And of course, we'll compare that best accuracy to the relevant accuracy we got with the standard version of the kernel SVM model, with a RBF kernel and the default value of 1 for that regularization parameter C, and then the same default value of the gamma parameter. So let's see. We have our data set, so we are ready to do this restart and run all. So there we go. 3, 2, 1, go. And yes, All right. So now the cells will be running. There we go. Grid search is now running, and we're about to get... Okay, so very, very interesting. We get a best accuracy of 90.67%, which is slightly better than this 90.33%, but you will see in your future machine learning projects that even a slight improvement of the accuracy can make a difference. And the best combination of parameters that led to that best accuracy is the following. First, a regularization parameter C of 0.5, meaning that indeed it was necessary to reduce a bit that hyperparameter C to reduce overfitting. Then of course we got the best accuracy with an RBF kernel, meaning with the kernel SVM model instead of the classic linear SVM. And the best value of this gamma parameter, when we have a RBF kernel, is indeed 0.6. All right, so it was actually good to test all of them, and that's what we get as the best model. So now feel free to try some other values, if you want, and maybe some other hyperparameters. And if you get a better accuracy than 90.67%, which I'm sure you can get easily, I haven't tried all the combinations, well, once again, feel free to share this in the Q&A section or in private message, but Q&A section is best so that other students can see how you did it. All right, and now we're going to move on to the very exciting final section of this course, the bonus section, which is about XGBoost and which will basically give you an extra super powerful machine learning model that you can actually both apply to classification and regression. So you definitely want this as the final tool of your huge machine learning toolkit. So I look forward to implementing this final model with you. And until then, enjoy machine learning.